Hi everyone, hope you're doing great. Welcome to another video in our Testing with AI series. You might have heard about Playwright MCP Server, which is gaining significant traction in the test automation industry. Today, we will try to understand what Playwright MCP is all about and how it can help with AI-powered end-to-end test automation, including automated testing of both browser and APIs. This video is divided into two parts. Part 1 will cover what MCP is, why it is introduced. Part 2 will cover how to use the Playwright MCP server for actual end-to-end AI-driven test automation. If you have been following my earlier AI series, I have explained how large language models or LLM work, including a bit about their internal mechanism. In a nutshell, an LLM takes an input which is called as a prompt and generate a relevant response. This slide deck depicts a simple working of LLM. Here the user submits a prompt to the large language model, which can be ChatGPT 4 or a Claude or Llama from Meta or Bard from Google, etc. The prompt is then added to model's context window. So the LLM has a context window which basically keeps track of all the transactions. Then the LLM processes the context and generates a response. It basically generates a response. The response is also included in the context window for the subsequent interactions. LLMs are incredibly effective at varieties of tasks like writing a Spring Boot application, summarizing the meeting notes, helping to draft the essays, and much more. LLMs are incredibly effective at varieties of tasks like writing a Spring Boot application, summarizing the meeting notes, and helping to draft the essays. In an industry, developers continuously use LLM to auto-generate the code or write a documentation, while the custom support team leverage them to create a quick response notes. But when it comes to executing a task like clicking a button or interacting with the web page or writing an email, LLM cannot do it alone. You can combine LLM with a set of tools to perform these actions. For example, you can combine LLM with the Playwright to interact with the web pages. You can combine LLM with an email client to send an email. This combination of LLM with a set of tools are called as an agent. In a simple word, an agent is an intelligent assistant powered by AI that not only understands what needs to be done, but also know how to use the right tools to do a particular task. Some of the examples could be like LangChain, OpenAI functions, AutoGen, Crew AI, etc. So an LLM agent is an autonomous or semi-autonomous system powered by large language model. So what does agents can do? Agent can understand a natural language task. Basically, whatever the query that is provided by the user, this is called as a prompt, it intercepts the user intent from the plain language. It basically intercepts the prompt and then this decides which tool to use. It selects from a set of tools that are available like APIs, functions, scripts, database, etc. Example, if your user query says, I want to go and click the login button of Amazon page, then what it does, it then selects a right tool that is attached to the LLM. It can be Playwright, it can be Selenium, so etc. So it selects the right tool to make an conversation or make an interaction with the web page. The agent then executes these tools. It can call the tools directly or via the APIs, such as running an SQL query, reading a file, using a Playwright to open the browser, filling a form and verifying the results and things like that. Then it intercepts the results, it understands the output of the tool and uses it for the next steps. It will continue to do the task until it is completed. So it performs intelligently, performs the reasoning and finishing the task and provides an output. On the right hand side, I have mapped some example tools for each of the steps that agent does. To understand the user prompts or to interpret the user prompts, it uses tools like ChatGPT, Claude or Gemini, and decides which tool to use. It uses agent framework like LangChain or QAI. To execute, it basically uses the tools directly like SQL, Playwright, or the request library, etc. To interpret the results, it is handled by the LLM reasoning. To iterate, the planning modules like React, AutoGPT, etc. So LLM with the bunch of tools can perform any kind of tasks. So when we are building an agent, we often need to integrate multiple tools. The LLMs with a collection of tools is a agent, right? So each tool might have its own way, its own APIs, its own standard way of communicating, custom connection patterns, complex authentication, different type of data formats, and etc. So managing the large number of tools, it is really becoming cumbersome and time consuming, and sometimes they are error prone as well. So that is when the concept of MCP is being introduced. The MCP stands for Model Context Protocol. MCP defines a standard way of communicating the different tools with the LLM. So that is why they call MCP as an USB-C for AI. Just like USB-C, how it allows the different devices to connect your laptop easily, MCP provides the standard way of LLMs to connect with the tools. The two core components of MCP are MCP client and MCP server. MCP basically follows a client-server architecture. Here client basically requests for the server capabilities like what resources it has, what prompt template it has, what kind of a tools it is being connected with, etc. And the server basically responds back with its capability. Now let us try to understand the architecture of MCP a little bit deeper. As I told, MCP contains two core components called as an MCP client and MCP server. The MCP client is hosted along with the LLM. Basically, they are closely attached to the LLMs. Okay, so if you see this black box here, under which we have set of LLMs, along with that we also have an MCP client that is being running. If you take an example of a laptop or a desktop where your LLMs are running, your MCP is also running in a same host. Okay, basically. So we can say MCP client as a library or a service that is running inside the LLM application or an agent that basically communicates with the MCP server using JSON, RPC over HTTP or WebSocket. If you see here, one MCP client can be connected to multiple MCP servers. What are the responsibilities of MCP client? The responsibilities of MCP clients are as follows. To discover the tools, it asks the server what tools and resources that are attached to it or that are available with the server. To access the resources, get the file, database or API from the server whenever it is needed. Then run the tools, start the tools provided by the server and manage their results. Send the request, convert the LLM instructions into a proper JSON RPC request and send them to the MCP server to identify its capabilities and to ask the resources from the server. To handle the responses, read and understand the responses from the tools that are attached to the server and pass it back to the LLM. And also keep the context, remembering the things like the tool results, the variable across the steps, etc. So it also pushes all the transactions into the LLM's context window. The MCP server is a standalone backend service that exposes the tools, resources, and the prompts in a standard format. The MCP server is a standalone service which is hosted outside of the LLM boundary. Okay. This MCP server basically listens to the request from the MCP client and process the request and responds to the client in the standard communication protocol that is defined between the client and the server. The key services that are provided by the MCP servers are the prompt template, resources, and set of tools. We already talked about a set of tools and resources. And what is this prompt template? A prompt template is a predefined structure used to communicate with LLM. It helps the MCP server to instruct the model how to interpret the user input and what kind of output to return. Think the prompt template as a recipe. The template basically defines the format, the tone, and the structure. Then the user inputs like a task or an instruction, he fills in the blank, and LLM follows the prompt to generate a consistent and useful result. There are two ways in which MCP server communicates with the MCP client. One is a local communication and another one is a remote communication. In case of a local communication, MCP server is hosted in a same machine or a desktop where you have an LLM and MCP client that has been running. Okay. So you can also host an MCP server in a standalone server away from the LLM and the MCP client. In such cases, it uses the remote way of communicating with the MCP client. What are the different responsibilities of MCP server? The first one is registering the tools. It stores and manages the tools that can be used by the LLMs. It exposes its capabilities, tells the LLM client what tools and resources that are connected or that are managed by the server. It executes the tools, runs the requested tool when the LLM client asks for it. Then it accesses the external resources like connects to the file, databases, or APIs needed. Finally, it sends back the result, returns the output of the LLM client in a format that can be understandable. Now that we have explored the theoretical aspects of MCP, it is a time to get hands-on with MCP. Now let us go to the official documentation of Model Context Protocol. So if you see here, this is an official documentation of MCP, and current version is version 2025-0618. It was released on the 18th of June. This is the latest version. So here you can explore or understand more about MCP, why MCP, what is MCP, why MCP is needed, general architecture of the MCP. As I told, MCP has got the two important components like MCP client and MCP server. The client is hosted along with your LLM like Claude or the ChatGPT or Bot, etc. So the server is a standalone component. They communicate each other using MCP protocol, which is basically in client server architecture. The server can be connected with the resources, the prompt templates, or the number of tools. Okay, this is what it is being defined here. And if you click on the quick start, we have a different guides that basically explains how to use the MCP along with Claude. They have used the Claude as an LLM here, and then how to basically do an server development, how to use it for the client development, and how to use the cloud desktop users. Okay, so it comes with the different language bindings, and if you see here, it comes with Python, Node.js, Java, Kotlin, and C#. So for my tutorial, I will be using the Python client. And if you scroll down back, it also provides you the relevant SDKs, right? So for C# there is a C# SDK. For Python we have a Python SDK. So we will use a Python SDK, And before that, what you need to do is you will have to install the Claude LLM on your desktop. Okay, so I have already installed basically the Claude for desktop. So you can go to Google and search for Claude for desktop. And you can install the relevant version. So in my case, I have already installed the Windows version of Claude Desktop. So once you click here, it will download the binaries, and then double click on it. It will basically guide you a process to install it. Once the installation is completed, you will basically see a first screen that is coming up, and click on get started. In the second step, it will ask you for a sign in. If you already have an account, then you can basically log in. If you don't have an account, you can sign in via your Google account, or you can create your own account with your email. Once this step is done, then you can readily use the Cloud Desktop. Now let me go and type Cloud. You say it is already basically linked to my account. If you see here, it's linked to a personal free plan. You can use a free plan, and you can also see my name coming. So it's like your chat GPT. You can initiate your transaction by writing some prompt here, and it will respond to your prompt. Yeah. So the cloud comes up with its own the MCP client. It is hosted along with the LLM. So here the LLM is a cloud desktop. Along with that, we also have an MCP client already coming in as a package. Okay. So now in order to understand the entire MCP protocol, how to use it, so we'll have to develop our own MCP server here. So for that, basically we can go back to their documentation and see how to develop it. So there is also a lot of example code that is available. I will be just copy paste their code. I'm not going to do more in this tutorial. In the next tutorial, we will explore a lot more on the Playwright MCP. So for a time being, let us go and create a small code snippet and try to interact with our LLM. What I will do, I will have to go for a server developer, and then I have to go to Python because I will be developing it in Python. Click on Python, it will take you directly to a GitHub project, and you can go through the entire documentation. So in order to basically use the Python along with the MCP, you basically need to install something called as an UV. So UV is the manager that manages your Python projects. Now let's go to the UV documentation. It says that it is an extremely fast Python package and project manager written in Rust. Okay, it's mainly used for managing the Python project, and you can install UV using pip. Okay, let us go and bring the command prompt. And let us do pip install UV. I think I have already installed, but this command will basically install the latest version of UV. So installation is basically complete, but you don't see anything here. If you have already installed UV, you will not see anything. So if you are reinstalling UV for the first time, then you will see a lot of steps that is being printed during the installation process. Now let us go and check the installation. Pip show UV basically prints the version that is being installed. Okay, so the installation is complete now. Now you can use UV to create a Python project. So what you need to do is you have to go to a folder where you basically want to create a Python project. So in my case, I want to create it under MCP, and from here you can bring the command prompt and you can basically take this command and paste it here. So the project is being created now, and you can go to the folder here and see there is a project that is being created. Now what you need to do is you'll have to go to this particular folder that we can do cd mcp, and then you'll have to enter this command uv add mcp cli, then add the mcp project to your project dependencies. Basically you're adding all your dependencies of your project using this command. Let us go and do this. It basically creates an virtual environment to run the MCP server. Okay, and alternatively for the project using the pip for dependencies, you can also use the pip install MCP client. This may need it or may not be needed. Let us go and do this here. Basically it is the same thing. This is completed now. Now what you have to do, you have to run the MCP command line with UV, you can use this command. Let us try to see what it does. Just a curiosity. So execution is completed. It has given some errors. Okay, this is because we don't have any implementation here. Let us go and do the implementation first and then come back. And for this, basically what you can do, you can copy or paste this code, and then you can go to the MCP server demo here, and you can create a Python file by name server.py. Then just copy the code, and if you see here, you are creating an MCP server. To create an MCP server, you need to have this module. Okay, so you need to import MCP fast MCP from MCP server. Then I will give the name as test troop here, server name as a test troop, and then I have an MCP tool here, and the tool basically does an addition. For a time being, I don't want a resource. If you see during my tutorial, I told that the server can have a tool, server can have a resource like a file or anything else, then file a database or something like that, and it can also have a prompt template. For a time being, let us remove this. Let us have only the tool. Okay, tool is simple and addition function. Okay, so now your MCP server code is ready. So now what we can do, you can go back and you can basically check whether MCP server is working fine or not. Okay, that you can do by using this command mcp dev server.py, and under which if I type dir, I have my server.py. So I will use this command to execute the server.py. The server.py contains the MCP server code. Let us go and check. This is basically checking whether my implementation works or fine before we go and deploy into the production. It is doing something. I think it is ready now. and it is giving basically the local host with the 6274, and we can also use the one that is enabled with the hotkey as well. So let us go and copy this. Okay, and if you use this as a standalone, sometime you will end up in having a trouble connecting to a server. Okay, so let us try to use this. This basically brings up MCP inspector, that is mainly used for checking your MCP implementation. Okay, and if you see during my tutorial, I also told that there are two types of connections. One is called as a local is also called as an STDIO. Another one is the streamable HTTP. Okay, so if it, since I am basically hosting the MCP server on a same host where I have an MCP client and my LLM. My LLM is a cloud here. I already have my LLM here. So it is in a same server. So I have to use the transport type as local. Okay. And now I have to make a connection with the server. Let us go and connect. Now the connection is established. Okay, now the connection is established, and if you see here, it gives different the resources, right? It has the server capabilities, key services that is provided by the MCP server are resources, the prompts, and the tools. So we haven't implemented anything as a resources and the prompts, but we only implemented the tools. Okay, if you see here, I have implemented only the tools. If I do Control Z, the code, in the code there was also an MCP resource, but I am not using it. I am only using the MCP, the tool, for a time being. So just to demonstrate how the MCP server can be implemented, let us go and explore the tool. The tools I can have got a list of tools. There is a add tool. When I add tool, it basically gives the two numbers, because if you see my code, there are two numbers, right? It takes the parameters as A and B, that is what is being displayed here, and I can give a value as 5 and 6. When I execute a tool, it basically gives the result as success, and it also gives you the result back as a 11. This is how basically the MCP, a simple MCP server that can be implemented. Okay, and we are basically running in a dev mode just to check the implementation of MCP server is correct or not. So what I will do, I will disconnect now, and I will also close this. Now our testing is completed. Now let us go and install the server. For that you need to use the command MCP dev server. Sorry, this one, MCP install server. Let us bring the command prompt and let us kill this. Yeah, it is what it says. The added server test troop to the cloud config, successfully installed test troop in cloud app. So what you can do, you can go to cloud and basically check if there are any tools. So it is still not got the update. What you have to do, you have to close the cloud app, and closing itself is not sufficient, and you have to go to the task manager. From the task manager, try to kill the cloud instances and task. Check for cloud. I think I don't see any of them. Let us close this and again come back. Now click on this particular icon, search for the tools. I think see we have a test troop which has got basically one tool. How does basically this happen? This happened due to the command. This command MCP install server. It basically added the server into cloud config. Let us go and inspect how does this configuration looks like. For that, go to file, then go to settings. Under the setting, you have a developer tab under which you see there is a test troop that is being running. Let us go and edit this configuration. It takes you into a folder where the cloud is being installed. This is a place where cloud is installed. App roaming cloud, your username. App data roaming and cloud, under which you have a configuration JSON. Let us try to open this. This is how the JSON looks like. It starts with MCP server, then under which you have your server name. Basically it picks a server name from here. This is your server name, TRROP. I made a spell mistake. The same thing has been taken here. Then it uses a command. Basically we are using a command called uv.exe to run the server. Okay, so then it uses a command called MCP run. Okay, and it runs the file like this. Okay, this is equivalent of going to a command line and then giving uv.exe and then basically running with these commands. Okay, so that is what it is being given. This basically tells you how to basically execute a particular the tool. Okay, that is what is being written in the configuration. Let us try to add another tool. So what I will do, I will just copy paste this, and instead of add, I will give it as multiply, and it takes two arguments. Here I will give it as C and D, then return C and D, then multiply, then the same thing we can multiply tool, multiply two numbers. I'll just go this. I will just save this and I will go to the command prompt, and in the command prompt I'll try to install this server. Okay, just before doing that, let us go and close our MCP server, and also from the task manager let us try to kill end task. Not killed. Now again try to run this. Getting executed. The configuration is also being installed. Now again go to cloud and open this. And let us go to the tool, and you see the number has been increased to 2. Okay, this is because we have two tools now. Go to the file, settings, developer, test troop, editor config, notepad. Nothing has been changed. Okay, and only we have not changed the way how to execute a tool, rather than we have increased one more the capability to our MCP server. Let us close this and let us try to do something. Just give a prompt as 5 plus 6 here. Sorry, 5 plus 6. Let us see what it says. So it says can I take help with calculating using available tools? It basically, yes, it takes my test troop, add as a tool, and try to execute that and asking for my permission. I will say that allow once. So it has been executed and the results been given. So basically it is making, so your agent, so you have an LLM, then you have an MCP client, then MCP client makes a call to the MCP server trying to understand its capabilities. That is where it gets listed down, and while user gives a prompt, then basically it uses the tool, the suitable tool that server has to execute it. Okay, this is how basically the end-to-end transaction that has been happens. So let us also give, now let us give like 8 into 4. Now it has to use a different tool. This is the agent. Basically agent here is takes a decision which tools to use. Okay, so the server, MCP server, registers the list of tools that is available with this, and it gives that capabilities to the client, and during the execution the agent decides which tool to use based on the capability. Now you see it uses the multiply tool. So I'll always give like always allow once, and it should give you a result as 32. This is basically how the MCP works. MCP is a model context protocol. It basically solves the integration problem with the different kind of tools that has been attached to your LLMs, because you will have to, different tools basically behaves differently. They have a different data format, data exchange, etc. So when you try to attach multiple tools to your LLM, it is hard for us to maintain. In such cases, MCP plays a very important role. It defines a standard for communicating between your LLM and the tool. Okay, the provider of the tool is responsible for implementing the MCP server. So the tool, so the Playwright is a tool, and Playwright has implemented an MCP server which can be easily integrated with any of your LLMs to take the benefit of automating your browser tests. Okay, so that part we will cover in our next session. That brings us to the end of this session. In this session, we explored the simple LLM workflow, and we also understood what are the actions that LLM cannot do. Okay, and then we saw how to integrate the tools into the LLMs, and that becomes an agent that handles the tool execution and things like that. Then we also saw the problems. What are the problems that basically we encounter when we try to integrate the different tools with a different capability, different data exchange formats, different data representations, etc., etc. How it becomes a cumbersome for LLM to manage that. So that brings a need of doing something as a standard protocol. That is where the MCP basically plays an important role, and it acts as an USB-C for the LLMs, where the different tools can be easily integrated. So the MCP has two components like MCP client and MCP server. The client will be a part of an LLM, where the server basically is an standalone. It's an standalone software that is running, where you can basically integrate with the multiple tools. Okay, it's the responsibility of the tool vendors to provide the MCP servers so that we can easily integrate with the LLMs. We also saw a simple example how to develop an MCP server and then attach this tool to the MCP desktop like Claude, and then basically executing the user prompts using those tools. Hope you enjoyed learning with me. In case if you find this video useful to you, please support me by subscribing to my channel. Thank you for watching.